This is the activity for lesson A3. In this activity, you will add a second LED and resistor combination in parallel with the first. Here are the supplies you'll need for this activity. First, the circuit from the activity in lesson A2. You'll also need a 220 ohm resistor and a blue LED. For this activity, you will be using the circuit you constructed during the activity for lesson A2. If you do not still have that circuit built on your breadboard, just pause this video, go back to the A2 activity video to rebuild that circuit, and then you can proceed with the rest of the activity in this video. So using the circuit from lesson A2 activity number 1 as a starting point, you will first add a second LED. Insert the anode of the LED into A15 and the cathode of a second LED into N115. Because the second LED you just added is functioning in parallel with the first, you will need to add a second resistor to control the flow of current. Connect a second 220 ohm resistor between P111 and E15. Take a moment to track with your eye how the current flows in the circuit and ensure you understand the path from battery positive through the components and back to battery negative. The positive lead of the battery is connected to P13 and powering the positive power rail. The current then splits into two separate paths. The first path is from P15 through the first resistor to E7, across row 7 to A7, and into the first LED and out to N17. The second path is from P111 through the second resistor to E15, across row 15 to A15, into the second LED, and out to N115. The paths merge at the negative power rail, flow through N13 to the negative of the battery. Now, if you'd like to continue to add the other resistors and LEDs in your kit to the circuit in parallel, just follow the same pattern. The number of resistors and LEDs included in your kit are safe additions to the circuit. However, if you're working with additional components beyond what is included in your kit, keep in mind that current is not an infinite resource, and you will eventually exceed the maximum current output rating of your power source. This is particularly true when you work with the Raspberry Pi in later lessons. Go ahead and disassemble the circuit and return the components to the kit and move on to lesson A4, where you will learn to use jumper wires in your circuits.